Hello everyone. Thank you for your interest in my paper. My name is Byung-do Oh from Hallym University. Now, let me start this presentation. I'd like to talk about the lightweight text classifier using sinusoidal positional encoding. As you can see, I have 6 main sections as follows. My presentation will take about 10 minutes. First, I'd like to talk about background. Convolutional neural networks achieved remarkable performance in computer vision. In text classification, it confirmed the good performance and efficiency of training time. However, it may occur losing the local information in the sequence. So many studies have found various methods for improving performance. Typically, they use pre-trained word vectors with fine-tuning. It leads to improving performance, but fine-tuning increases the parameter cost for training in proportion to the sequence length. And larger and more complex models are carried to improving performance too. However, it requires the numerous parameters. So, in recent years, some studies have been conducted to reduce the parameter and computational cost without significant loss in performance. A representative study on this is Transformer. Transformer uses multi-head self-attention and sinusoidal positional encoding. Especially, sinusoidal positional encoding provide effective position information of word without RNN, and it represents to position information with parameter free. In computer vision and NLP, some studies have been conducted to confirm its usefulness. So we explore an efficient way to ensure equivalent performance with less parameter cost than before. We use CNN because it has high efficiency of training time through GPU, and we use sinusoidal positional encoding for parameter-free based position information. From now on, we will call this SPE. So we consider it as a method that can reduce the parameter cost without fine-tuning for each task. Figure 1 is our proposed model architecture. I will explain this in more detail in next slide. SPE uses different functions for even and odd numbers in each word vector. As shown in the figure below, even numbers use the sine function, odd numbers use the cosine function, and in equation, pos is position of a word in the sequence. This position information added to each word vector, it can be represented the same word differently. Single CNN is only used as feature extractor. At this time, we set the size of convolution filter is 3. And we used max and average pooling layer for extract more various features. In convolution layer, we use layer normalization, and when pooled features are getting into fully connected layer, we use dropout for regularization. In the experiment, we use 6 benchmark datasets. The contents of this are shown in table 1. And we use globe vector, which pre-trained with 840 billion words. It is represented in 300 dimensions. In convolution and embedding layer, we use the L2 regularization is set to 0.0001. We use the linear function among the activation function in CNN. and dropout rate set to 0.1. This is experimental result of parameter size and training time. We compared them with CNN-based approach to confirm the usefulness of SPE in CNN. As a result, our proposed model reduced the parameter size by at least 67% compared to the previous model, and the training time was reduced by up to 90%. And it was confirmed that CNN static, which is without fine-tuning, was similar to the proposed model. And we confirmed the performance about proposed model with CNN-based approach. The proposed model was able to maintain similar performance despite significantly reducing the parameter cost compared to previous studies. Additionally, we also confirmed the usefulness of SPE in simple bag-of-word-based word vector. However, SPE is designed to compute the position information from word vector based on distributed representation. So we confirmed that it seemed difficult to provide effective position information in simple bag-of-word-based word vector. Finally, we compared SPE and fine-tuning. Kim confirmed the usefulness of fine-tuning for pre-trained word vectors. It is still used in many studies. However, it requires additional parameters in training. As shown in Table 3, we confirmed that the position information of SPE in CNN can have the same effect as fine-tuning. In this paper, we explore an efficient way to ensure equivalent performance with less parameter cost than before. So we use CNN and SPE, and we try to confirm the usefulness of SPE in CNN. In the experimental result, the proposed model was able to maintain similar performance despite significantly reducing the parameter cost compared to previous studies. And we confirmed that the position information of SPE in CNN can have the same effect as fine-tuning. We expect that SPE can be used more efficiently in CNN-based approach in the future. And in the future, we extend to study a method that can easily learn the position information of word in a manner other than SPE. Thank you for listening to my presentation.